So hi everyone, I'm Matt Houghton. I'm an AWS certified engineer. I work at a company called CDL. You've probably never heard of us, that's okay. CDL is a UK-based technology services provider. We're listed in the Financial Times Future 100. We're an AWS, part of the AWS Partner Network. Just last night we won the Best Use of Data in the UK Business Tech Awards for our real-time data intelligence platform called Hummingbird. And basically, our software processes high volume retail transactions for customers such as Tesco Bank and Swinton. If you've ever bought insurance in the UK for a price comparison site, about half the prices you'll see on screen will have come through one of the solutions that myself and my colleagues build and run at our campus in Stockport. So kind of providing a way of putting data in the hands of decision makers that's really vital for us and our customers. Because by ingesting and harnessing data, we're able to get best indicators of who consumers are, and then we can personalise and make the best decisions to deliver products in a simple, engaging way. So I'm part of the kind of data engineering team at CDL, and when that team talks to customers, we see quite a lot of similar challenges that they're facing. So everybody's requesting access to data to help them make decisions, and customers generally have a kind of business intelligence or MI platform that's been designed generally just to run a kind of standard set of reports that are required to run their business. And if they get requests from across the organisation to start running different queries, then typically the systems that they have don't tend to scale well. You see things like, waiting to add indexes to kind of relational databases, perhaps database administrators being a bit protective over the kind of standard SQL that's running and wanting to protect the core business. And it doesn't tie into kind of innovation and ideas that the business might want to try out. Because we're really seeing a trend for new ideas and trying out different analytics services such as machine learning. And without data, there is no AI. So if your existing data infrastructure is off busy running your kind of current operations, then where are your kind of innovators and data analysts going to get their data from? Indeed, people like Google and Kaggle in their State of Data Science and Machine Learning survey agree with this. So in some industries, up to 92% of people will say that bad, unavailable or difficult to access data is one of the top barriers to success in data and analytics projects. And we're also seeing that the volume and type of data that organisations need to store and process is increasing. And kind of traditional large data appliances that perhaps used to run 24/7 are often unsuitable when designing and implementing a cost-effective data architecture. So as I said, we're seeing storage and management and analysis of data today requiring analytics services that need to scale and perform in ways not possible before. And as engineers, we're really fortunate that cloud services, like those from AWS, are providing lots of new features and the capacity to process large amounts of data. Now don't worry, I'm not going to describe every icon you see on screen, and that is just a small subset of the services that AWS and their competitors like GCP, Azure provide today. So as engineers, often the difficulty now is picking the right tool for the job. So in this talk, what I want to do is just highlight what I think are some really cool and useful services from AWS that you can get started with to build out a modern, scalable, cost-effective data platform that's going to be flexible enough to solve challenges that we have today and in the future. So let's narrow down that list. An important aspect about architecting a cost-effective data platform is the ability, I think, to decouple storage from compute layers. So ideally, to support different types of analytics workloads, what we need to do is be in the position where we can store our data and only spin up and consume compute resources when we're actually running queries against the data. And the services you see on screen, they allow us to do this. So we're going to do some video demos. So we're going to use S3 for storage. We'll discover and classify data using a service called Macie and trigger events processed trigger events from Macie and process them using Lambda functions. And what we're going to do there is automate our security posture, data governance and compliance rules. We'll perform some ETL operations using a service called Glue, and we'll run SQL queries using Athena. And we'll also take a look at AWS Comprehend as just one of the many ready-baked machine learning services that AWS provides. And finally, we'll put some data in the hands of decision makers by using the AWS business intelligence service called QuickSight. Okay, so a bit of an intro into some of those services. In S3, data is stored as objects within buckets. Each object can store up to 5 terabytes in size. And you can use different storage classes to migrate objects between the different storage classes using lifecycle policies. And this helps you to get the balance right between availability, durability, and cost. And then there are complementary AWS services that allow you to query the data in place without needing to copy or load it into a separate analytics platform or data warehouse. So S3 provides up to 11 nines of durability. To put that into context, if you were to store 10 million objects in S3, you would only lose one of those objects every 10,000 years. So it's an incredibly robust service for storing your data. Okay, moving on to kind of governance. Macie, it's a fully managed service that uses machine learning to automatically discover, classify and protect your data. In particular, sensitive data such as personally identifiable information, PII, or things like intellectual property. It continuously monitors your data access activity for anomalies, and it will generate alerts and events. And what I really like about Macie is that you can use these events that it generates to automate your data platform, security posture and data governance rules. So for example, somebody loads a file containing PII data, we'd automatically take an action to apply, say, a specific access control policy or add some tags to that object appropriately. Lambda, this is a serverless compute service. It allows you to run code without having to think about or manage the underlying compute resources. And we only pay when we're actually executing our code, which is generally triggered by an event such as from another AWS service like S3. As we're not worrying about the servers, it's going to free up our time to concentrate on functionality. So in this talk, I'll use Lambda to provide that custom logic to implement our data governance rules. Okay, so here we have a kind of target architecture for storing data and automating that data governance and security posture. Storing the data in S3, we're going to pay about 2 cents per gigabyte on the standard storage tier. And Macie's been configured to constantly monitor the S3 bucket for changes in the data, and in this example we're going to upload a file containing PII data. Macie will detect that PII data and it will generate an alert which will be available for viewing via the Macie dashboard. The alert will also generate an event into CloudWatch, and we've set up a CloudWatch rule to capture that Macie event, put it onto a queue provided here by the AWS SQS service. And then often we kind of find that organisations will have an existing kind of security information and event management solution in place, and it's really simple to integrate the kind of SIEM solution that you might already have with the data from the CloudWatch rule too. At CDL, we push CloudWatch data into Elasticsearch at the cloud platform level, and this allows all the development squads to take advantage of that without having to build that each time themselves when they build a new application. In terms of the code that's going to implement the data governance rules, we've got some Python code and we're going to run that via Lambda to consume the messages from the queue, and if they relate to that PII alert, we'll add a new tag to the object in S3 to kind of categorize it as sensitive data. All these services, they're managed for us by AWS. We don't have any infrastructure to build. Okay, so hopefully you can see the video. So first of all, we're going to upload some data into S3. So this is the PII data that I talked about before. At the moment, if we go into the properties on it, you'll see that there are no tags on the object at the moment. So this is test data that I've generated from a website called mockaroo.com. If you're into building test data that looks like real data, but it's not, Mockaroo is a great resource. So it might look like real addresses, but trust me, it's all okay to show you. So this is Macie, and it's scanned the S3 bucket, and it's classified the data based on the contents and also the metadata, and it links them to what it calls themes. So in this case, it's linked it to a theme of JSON data, because that's what it is, and it's also linked it to a theme of having large amounts of US phone numbers. And because the volume of data in the file, it's rated the impact if this data was to be lost as high. We can see more details as we go through. We can see things like who owns the data, what type of PII data, so names, addresses, phone numbers, IP addresses. It's detected all of those, email addresses. And we can click through into CloudTrail from within the Macie dashboard to see the events where people have actually had access to this data. So there's a couple of events you can see there. And you can see this is the bucket that Macie is monitored. And because of that detection, it's actually generated an alert here that we've got potentially personally identifiable information being uploaded to S3. So you can see it's JSON data, it's got audit keywords, it's got large amounts of US phone numbers, zip codes, etc., etc. Okay, so because of that alert that's been generated, it's put a message on the SQS queue. So you can see the message. Basically, that's just a JSON blob of data containing the information from Macie. So again, it's saying we've detected PII data here. Clicking through to our Lambda function, you can see that's consuming the message off the SQS queue. And we can look through and see the number of times the Lambda has been executed, and we can see the output from the code in the CloudWatch logs. So you can see here it's picked up the information and it's gone to the object in the bucket, and it's added a tag to this object in this case to say PII is equal to yes. So it's tagged the object as being sensitive, but we could have done anything there because it's bespoke code. We could have restricted access by applying an ACL. We could have deleted the object if that's not a bucket that we should have that type of data in. We could have locked it down to a set of users that are allowed to see it, and declined access from users that aren't allowed to see that sort of stuff. So it allows us to load data and completely automate those kind of data governance and compliance rules, no matter how complicated they might be, because we can implement that in code. Okay, so move on to some other services. Glue. This is a fully managed extract, transform and load service, so ETL. You simply point at your data stored in AWS, such as S3, and it will discover the data and store the associated table definitions and schema into a data catalog for you. It also provides code generation for the ETL, and it also allows you to write your own code in Scala and Python. And it's got a flexible job scheduler for running the ETL jobs. Those can be based on time or via events. So upload a file to S3, a job would run. And once again, AWS are managing all the underlying infrastructure for us, and we're just paying for what we actually use. Okay. Athena. This is an interactive query service that allows analysis of data in S3 using standard SQL. You'll probably spot a theme in the services I'm talking about. Once again, Athena's completely serverless, there's no infrastructure to manage, and you only pay for the queries you're actually running. And it's integrated with the Glue data catalog. The way the pricing works is you pay for the amount of data scanned, which is $5 for every terabyte. But you can optimize those costs by using things like compression, partitioning, and converting your data for things like JSON and CSV into formats like Avro and Parquet. So here's a kind of target architecture for ETL and query. Data, as always, stored in S3. AWS Glue uses what's called crawlers to scan the S3 bucket, and those crawlers will identify the type of data stored and the schema. And it adds that metadata to the Glue data catalog, which then can be used by a few different AWS services, including Athena. The data we're adding in this example is JSON, and we're going to convert that into Parquet to improve the query performance and reduce our costs. Glue's going to run an ETL job where we've got some Python code to do that conversion from JSON to Parquet, and it'll store the results in a different S3 bucket. From there, another crawler will discover, identify, and catalogue the Parquet version of the data into the data catalogue. And finally, we'll run SQL directly against that data in S3 using Athena. You can access Athena through the AWS console, but it also has JDBC and ODBC drivers that you'll have to connect up popular BI and query tooling that you might use today. Okay, so here's a video demo. So we've got some data in S3 already. It's a JSON file. It's about 1.2 gig in size. So now we're going to go to Glue. So in the Glue data catalog, all we have at the moment is a kind of logical database. There is no physical database sat behind the scenes. We're not running any infrastructure, and at the moment it doesn't have any tables in it. We've got a Glue crawler here that's set up to run once an hour, but for demo purposes we're just going to execute the crawler now. Okay. So you can see here that the crawler has identified a new table, and it's added that to the Glue data catalog. So here's the table, and if we scroll down, it's classified it as JSON, and it's picked out from the JSON all the field names and all the data types. So that's all that metadata is in the catalog now. So this is an ETL job in Glue, and it's going to convert that JSON data that we've discovered into Parquet data. Again, you'd schedule this up to run normally, but for demo purposes we're just going to execute the run now. Okay, and we can click through and see various details about the job. You can view all of the code within this console as well. So I didn't write any of this code. This was generated for me by Glue as well, but you could customize that or go completely as bespoke if you wished. And it's also got built-in metrics, so it's not doing particularly much work in this particular case, but you can see things like the number of times it's been executed, kind of how many kind of logical processing units it's using, etc., etc. So it's kind of well under 50% utilising for the compute that's allocated to it. And it's all integrated into CloudWatch, so the output from that code, you can view the logs in detail if you wished. Okay, so going back to the S3 bucket, the JSON's now been converted into Parquet, so you can see the .parquet extensions on there, and we've kicked off the crawler to discover that Parquet data. Okay, so it's added that to the data catalog. We've got one table added there, and you'll be able to see that as a new table in there. And again, if we click through, we'll see all the metadata, classified it as Parquet, and it's picked out all the columns. We also took the opportunity to change some of the data types, so converting strings to dates and things like that. And again, all the logs are available in CloudWatch, and you can click through to see those within the console. Okay, so over to Athena. We can now run SQL against those files stored directly in S3. So we've not had to load it into a database. We're not paying for, Postgres to be running on compute or whatever, or MySQL, whatever your particular flavor is. We're just going to run normal SQL, first of all, against the JSON data. So we're just doing a count and grouping by city and car make. So you can see this has taken about 3 seconds to run, and it's scanned the entire JSON file, which is 1.23 gig. If I switch the table to run against the Parquet data, it runs slightly quicker, 2.84 seconds, but you can see the amount of data scanned has gone down to 7.4 meg. So there's a massive difference just on a relatively small file of that size. So what this means for us, remember we pay for the amount of data we scan in Athena, not how long the query actually takes. Scanning 1.2 gig data versus 7.4 mega data, the second query is going to be a lot cheaper for us. So it's a really cool feature. Okay, got to talk about machine learning, I guess, at a big data conference, but I'm not a data scientist, and but what we find is that a lot of machine learning is ready baked for us, and Amazon on AWS, they have loads of services you can just consume. So Amazon Comprehend is one of those services, and Comprehend makes it easy to find insights in and relationships in text. So we see a lot and speak to a lot of customers who are asking to get insight into kind of more unstructured data. So things like emails, call center recordings, social media. We've implemented recently kind of voice automated call centers, virtual call centers, and chat bots into our applications, and they're generating tons of transcripts. Our customers want to understand the conversations that customers are having in that kind of digital virtual world. So using NLP, natural language processing, we can identify the language of the text, we can extract key phrases, places, people, brands and events, and I guess most importantly for the customers we speak to, they want to understand kind of whether those interactions with their customers are positive or negative, so we can understand the sentiment that's in those texts. So here's a target architecture for kind of running any of the machine learning services available really in AWS, but we're going to focus on NLP, the Comprehend service, but you could easily swap out that green box at the top there for one of the other ones. So what happens in this kind of target architecture, we're going to upload some conversational data from maybe one of our chatbots into S3. That generates an S3 event, which is going to trigger our code, which is being run via Lambda. The code in Lambda is going to call out to the machine learning service in AWS, analyze all the language, do all the sentiment analysis. We're not going to have to be data scientists and do all that. The result will be returned back to the code, and we're going to store the results into another S3 bucket. And then, just like we've done in all the other demos before, we'll use Glue and Athena to discover, catalog, and query the data. Okay, so here we go. First, upload some conversational data to S3. So I've got 4 conversations here, and these would contain feedback from customers. Might have come from Twitter, call transcripts, emails, doesn't really matter. So as the Lambda function that we've got set up is set to trigger on when somebody puts data into that S3 bucket, we can click through to the monitoring, and we'll see that the monitoring will show us that it's been executed 4 times. So there you go, the little blue dot that you'll probably struggle to see. Trust me, it says 4. Click through to the CloudWatch logs, we can see the output from the code. So for each file, it's downloaded it, called the machine learning service, got the output, and saved that result into S3. So as we've done before, we want to catalog that. So we've got a crawler set up here. You'd probably set this up on a schedule, but we'll run it in an ad hoc fashion for the purposes of the demo. So scan that output in S3, and it's going to add a table to our data catalog. So it's added a new table, and here we can see the metadata. So we've got the name of the source object, the language score, sentiment, a few different columns like that. Back over to Athena, we want to be able to get some insight out of that, so we're going to start querying it. So we're going to do a count and get the average language score from the sentiment analysis that we've just done. So a couple of seconds, so we're 99%, so our customers are happy, which is good news. If you want to dig into a bit more detail, we'll just do a count star against that data. We'll get the 4 records back, and you'll be able to see the individual values. So one of the messages came back as negative, the other 3 were all positive, and you can see the different scores between them. Okay. So this service we can talk about now is called QuickSight, and QuickSight's a business intelligence service powered by the AWS cloud. And its aim is to deliver insights into everybody in your organisation. With QuickSight, you can connect to multiple data sources and create and publish interactive dashboards. QuickSight dashboards can be accessed from any device, and you can also embed them into your own applications. They can include machine learning powered insights which monitor for trends in the background on your behalf as well. One of the features I really like about QuickSight is the cost optimization that AWS have done around it. So it has the ability for you to pay per session. So it has a pay per session pricing option, and this is 30 cents for every 30 minutes. And what's cool about this is we've got kind of lots of customers and our own internal business as well, where we've got ad hoc users of data. They want to make a decision, they'd like to see the data to support the decision making process. They might not access that data then for maybe another month until their kind of decisioning cycle comes back around or something like that. So by being able to pay per session, this allows you to open up data through QuickSight to all users in your organisation. And they can access the data then when they need to, and without paying for what are more commonly, I think, more kind of read-only pay monthly or pay annually subscriptions, which kind of assume that users are using data and doing dashboards all the time as part of their job, which, you know, in a lot of cases do have a lot of ad hoc data users in organisations. So compare it against similar tooling, I think that's a really cool feature that's worth looking at. Okay, so quick demo of QuickSight. We're going to load some data into QuickSight. Could just as easily consume the data from S3 through an Athena query. There's lots of other things, relational databases, pick your flavor, it's supported, as well as kind of software SaaS providers like Salesforce and Jira as well, that's all supported. And QuickSight helps us build visualizations based on the type of data as well. So I'm slightly running over here, so I'm going to try and speed up this video. So say we didn't know about this data, this kind of auto graph you see here would actually suggest the type of visualization simply based on the type of data here, and it's just a case of kind of dragging and dropping values onto the boxes and it producing a graph in kind of real time for you here. Okay, so if we need the type of visualization as well, again, pick a pie chart, drag and drop the things that you're interested to do onto the boxes, and it's all done for you. Change it from a sum to an average. Down the left hand side, what this is doing is actually generating insights in real time. So it's actually suggesting interesting things in English language about your data. The other thing is, again, you don't need to be a data scientist to do machine learning. It's got built-in things like forecasting and anomaly detection. So simply you say, I want to do some anomaly detection. You define the schedule of how often this is going to run. You tell it the fields that you think might be interesting in terms of anomalies. And you say, right, away we go, save, run it once. This is a very shortened version. It does take some time actually in the background to run all this, but it will actually pick up unusual things in your data. So in this case, school supplies are a lot higher in the US than they normally are. So you can see the anomalies spikes here in data, and that accounted for a 24% increase in revenue, and it resulted in 100% of the total revenue increase overall. And there's loads of like built-in kind of classifiers and different insights that you can generate. So computations, bottom ranked, top ranked. There's a whole set of them out of the box that you can just plug in and play with. So it's just a really cool feature. Okay, last slide. Business intelligence staff, we find, are often very busy people, so rather than have a decision maker have to wait, we thought it'd be a cool idea if our customers were able to kind of have a self-service business intelligence function that offered them convenience. So you can think of this example you see now as decision makers having their own virtual BI team. Alexa, open CDL Kingfisher.
Welcome to CDL Kingfisher voice-powered analytics. Please tell me what metrics you'd like to hear.
How many policies sold?
The value for policies sold is 100.
Okay, so that's an example that we set up for kind of one of our insurance customers, and we can sort of imagine having that in kind of a CEO or CDO, CIO type office, CXO office, and being able to ask kind of simple queries that then frees up their kind of BI staff to get on and do the more complicated analysis that they actually need to do to help the business. So I hope this talk has shown just a very small selection of the great data and analytics services that are available on AWS. Now you perhaps could combine them together into some sort of target architectures to design and implement a really cost-effective and flexible data platform. Because by ingesting and harnessing data, we're able to get the best indicators of who consumers are, and we can then personalise and make the best decisions to deliver products in a simple and engaging way. Thanks very much for listening.